Hello everyone, and first of all thank you for clicking on this video. Myself Pratik and I am here with my group members to explain you about the execution of complete instruction. The division, name of the student and their respective roll numbers are displayed on the slide. So beginning with me, I will introduce you with the instruction cycle. The instruction cycle, also known as fetch, decode, execute cycle, is a cycle that central processing unit, that is CPU, follows from boot up until the computer has shut down in order to process instruction. The instruction cycle in a simple computer includes the steps listed below. First of all, get the instruction from memory, that is fetch instruction. Then decode the instruction. Next comes from memory, read the effective address, and lastly execute the instruction. These instructions are carried out by processor of computer. I hope the picture here is self-explanatory to what I discussed. Moving to next topic.
The first stage is fetching of an instruction. For this, there is a program counter which stores address of the next instruction to be performed. Now there is something called sequence counter, which whenever a clock pulse is applied, we get a timing signal T0. When again a clock pulse is applied, we again get a timing signal T1. Like this it goes on. Now during T0, the address of the next instruction stored in program counter is loaded into address register. The next is during T1. The instruction is read from the memory and it is then loaded in instruction register, that is IR. This is now over for the first instruction cycle. For the next instruction, the PC is incremented, which means the address of the next instruction to be performed is again stored in program counter and the whole process restarts.
Good morning, I am Aditya Mandke. So I am going to explain decode instruction. This instruction is used to decode user-friendly language to machine-understandable language. Once an instruction is fetched, it is decoded so that further execution can take place. Let's get to the further instruction.
Hello, my name is Sahil Mandare, roll number 27, and I am going to explain the role of ALU in the execution of instruction cycle. So, the arithmetic logic unit, the ALU, plays a crucial role in the execution of an instruction cycle in a computer's central processing unit, the CPU. It is responsible for performing arithmetic and logical operations on the data in the CPU. During the instruction cycle, the ALU receives instruction and the operand from the CPU and executes the specified operation, producing the result which is then stored in the CPU's memory. The ALU is fundamental component of the CPU. Without it, the CPU would not be able to process and manipulate the data, making it an essential part of the computer system. So, moving to the next topic.
Hello, I am Atharv Mandpe. I will be explaining the access memory and update register file. First, let's look at access memory. There are only two memory access instructions, load and store. A value from memory is copied to register by load and the register value is copied to memory by store. This all happens in four stages, namely fetch instruction, decode instruction, read address from memory and execute instruction. Let's look at them one by one. The first is fetch. In this, the CPU retrieves the information or instruction from memory. The next is decode. In this, the CPU decodes the instruction in order to understand which operation to perform. The next is read address from memory. In this, the CPU retrieves any operands which are specified by the instruction from memory. And the last is execute. In this, the CPU performs the operation which is specified by the instruction. Now, let's look at update register file. The ALU, that is the arithmetic and logic units output, is returned back to the register file in this phase to update the register file. It is also possible that the result is due to a load from memory. The update register file step also happens through four stages. They are fetch, decode, read address and execute instruction.
So let's understand what is update program counter. Once the complete instruction is executed, the program counter is updated to the next memory address. Due to this, it is able to execute upcoming instructions. Thus, fetch, decode, execute cycle will again take place. Why is this instruction required? An instruction cycle for a computer system is required to properly comprehend the flow of instruction and the execution of an instruction in a computer processor. It deals with the entire flow of instruction from the time when system boots up to its shutdown. That is, we can understand internal flow of instruction cycle. It deals with the fundamental functions of a computer processor and its necessities through understanding of the many phases involved.
So let's move to the last part of the presentation, that is significance of instruction cycle. The instruction cycle are the basic action executed in the CPU's main memory, which is why they are crucial for the processor. It is series of phases that aid in comprehending the flow of instruction. The instruction cycle allows the computer processor to visualize instruction from beginning to the end. The processor time can be easily calculated using instruction cycle, which helps us to determine the processor speed. Now, it is usual for all instruction set to require a thorough understanding to perform all operation efficiently and at least error. The processor speed determines how many instructions may be performed in the central processing unit at the same time, which helps us to determine how good is the processor. It makes the computer more efficient and user friendly due to this instruction set.
Thank you for watching the video. Please ask the questions in the comment box below.